Welcome back, Neutron Tech HD crew. Today we follow Hiếu Hiệu through something genuinely remarkable, a full homestead built entirely on her own. No crew, no heavy equipment, just her hands, a few basic tools, and a will that doesn't quit. Watch closely and you'll see this isn't improvisation. Every choice she makes reflects a solid grasp of how building actually works. Using materials that are easy to source and built to endure, she's putting up a permanent, self-reliant structure right out in the countryside. The foundation rests on hollow concrete blocks set in cement mortar. Those blocks are well suited for a solo builder, much lighter than solid stone, without giving up any real strength. Ceramic tiles on the exterior walls aren't just decorative, they serve a practical purpose too. Stone-textured blue and white tiles give the surface the appearance of natural river rock, while keeping upkeep simple. Corrugated iron sheeting adds rigidity to the roof, and its smooth face channels rainwater off quickly. The sloped gable form does quiet but important work. It deflects wind and lets hot air escape through the peak, keeping the space below more livable. Moving to the kitchen, she starts by raising load-bearing pillars, keeping each one plumb with the help of guideposts. Hollow red clay bricks are her material of choice. They handle pressure well and resist heat transfer, which matters a lot in a cooking space. Cement mortar holds each course in place, drawing its strength from a chemical reaction between lime and silicates as it sets. Beneath it all, compacted earth gives way to a concrete slab, a base that spreads weight evenly and keeps moisture from rising. Moving to the kitchen, she starts by raising load-bearing pillars, keeping each one plumb with the help of guideposts. Hollow red clay bricks are her material of choice. They handle pressure well and resist heat transfer, which matters a lot in a cooking space. Cement mortar holds each course in place, drawing its strength from a chemical reaction between lime and silicates as it sets. Beneath it all, compacted earth gives way to a concrete slab, a base that spreads weight evenly and keeps moisture from rising. Next comes the cooking platform itself, a hollow brick frame with steel rebar mesh running through the concrete. That grid of steel changes everything. Without it, the slab would be brittle, but with it, the surface becomes load-bearing and heat-resistant. Circular openings are cut into the slab where the burners will sit, each one fitted with a metal ring formed and welded from rebar. Those rings act as heat collars, pulling thermal energy away from the flame and spreading it outward, which protects the surrounding concrete from cracking. Once the inner structure is complete, a smooth concrete layer goes over everything, sealing it off and leaving a clean, finished surface. As the kitchen takes shape, steel profiles go in as connecting beams and roof supports to tie everything together. Beside that section, wooden molds, simple rectangular frames, are set out to cast each concrete tile to the same exact dimensions. Used again and again, those forms keep every piece consistent, resulting in a layout that looks intentional and fits together cleanly. Once the pattern cures, grass fills in around it, softening the appearance while also helping to regulate the surrounding environment. Attention then shifts to the ground, where an excavator levels the terrain to create a stable, even base for everything above. Getting the slope and drainage right at this stage matters. Neglect it, and you're setting yourself up for erosion and uneven settling down the line. Along the walkway's edges, rows of red clay bricks are set into a mortar bed, marking the borders of the path and anchoring the whole layout firmly in place. While the concrete sets, Hiếu Hiệu pulls the molds free and lays the pavers along the planned curve. The gaps between them get filled with soil and seeded with grass, letting rainwater soak in rather than run off. Coming up is one of the most impressive parts of the entire build, the water wheel. It all begins with bamboo supports, cut and set in position to hold the main axle steady while construction gets underway. Over the bamboo frame, she mounts a metal shaft, a steel pipe with a circular plate on each end. From there, she welds spokes outward in all directions, building the wheel's core skeleton. Those welds don't just hold things together, they're what allows force to travel smoothly from the center all the way out to the rim. With the frame in place, she attaches wooden paddles to the outer ends of the spokes, each one angled deliberately. The water needs to meet the paddle at just the right point to push the wheel into motion, converting the river's straight-line flow into rotation. She then wraps thick polyethylene pipe around the outer edge to reinforce the rim. With the wheel done, Hiếu Hiệu heads to the river to sort out the foundation. Old tires get stacked and filled with concrete, a practical reuse that creates solid cylindrical bases tough enough to handle constant water erosion. Wire cages packed tightly with rocks are then placed along the bank, locking the main base in position against the current. The orchard is where you really see how methodically she thinks, turning bare ground into a productive, well-organized growing space. With the outer boundary set, she fills the inside with packed earth and spreads a layer of sand across the top to level it out. Between the brick rows, she uses a hoe to shape long raised ridges, giving roots the room they need to spread. Granular fertilizer goes into the furrows next, getting nutrients into the ground before anything is planted. She then sets young seedlings in straight, evenly spaced lines so each plant has room to catch light and breathe. For the next phase, river stones get loaded into a wheelbarrow and brought over to build walls around the orchard's outer edge. Each one is set by hand and fixed with mortar, forming low barriers that hold the planting beds in place. For the entrance, she welds metal rebar into a semi-arched frame. That gentle curve matters. It softens the stonework's hard lines and gives the gateway a more natural feel. She then builds wooden double doors from raw planks, cutting, nailing, and framing each piece with care. With that done, the next build is a chicken coop, practical, low impact, and designed to fit naturally into the surroundings. She digs a rectangular trench with a hoe, marking the boundary and setting up for proper drainage. Wooden planks go in vertically along the edges, staked in place to form the molds for the concrete footings. The columns holding up the roof are ones she makes herself, plastic sheets rolled into cylindrical molds, tied off with wire, then filled with concrete. Their height isn't left to chance. It's calculated to give a person comfortable access for cleaning and upkeep while keeping predators out. From there, she welds a lightweight steel truss for the roof, locking the cross members at right angles so everything holds firm. That metal surface does double duty. It reflects sunlight back, keeping the temperature inside manageable. She then wraps the coop in galvanized wire mesh, pulled tight against the frame with tension hooks. Stone, steel, and mesh together create something sturdy enough to last, open enough to breathe, and perfectly suited to a tropical climate. Next comes the fountain. Once the outer ring of stones is in place, she packs the gaps with a wet cement mix. A wheelbarrow keeps the material moving, more stones brought in and built up steadily. Large and small pieces alternate as she goes, with mortar worked in between to bind everything into one solid mass. With the pond's main basin done, attention shifts to a smaller conical mound of stones rising up beside it. Before that mound is closed off, she feeds a flexible PVC pipe through the lower section of the stone wall. The plumbing goes in while there's still access. Then she returns to the basin and smooths a thin layer of cement mortar across the bottom. Inside, she cuts flexible foam panels designed to mimic the look of brick, each one a vivid turquoise blue. With the flooring finished, she fits a small raised platform into one of the corners, which will serve as the bed. Outside again, the electrical work is next. She climbs a wooden pole to attach the upper length of wire and get the overhead connection in place. With that secured, she heads back inside to wrap up the rest of the installation. Here, it's worth stepping back to appreciate the scale of what's actually being built. In rural Vietnam, particularly across the northern provinces, a homestead is far more than a place to live. These are self-sustaining systems shaped by generations of practical knowledge, passed down and refined over time. Nothing here sits idle. Every square meter plays a role in an ongoing cycle of production and renewal. Vegetable gardens, fish ponds, poultry coops, and fruit trees, all sharing the same space, each one supporting the others. That layout keeps food on the table year-round with very little waste. It's a living example of how prosperity and sustainability grow from carefully weaving nature and human effort together. The stonework itself draws from techniques passed down over generations, but step back and look at the whole picture. What takes shape is something far more intentional than tradition alone. Something remarkable is happening across Vietnam, a quiet but powerful movement pulling people back to where they came from. Much of it is being led by young Vietnamese who spent years in cities before realizing what they'd left behind. What they're building now isn't just a house, it's a complete way of living. One that grows its own food and nurtures the mind as much as the body. Building this well captures that spirit perfectly. There's a deep understanding here of how resources move in a cycle. Water feeds the garden feeds the family, and everything stays connected. Instead of depending on outside systems, These builders go back to basics, creating their own water supply from scratch. Water in Vietnamese rural life has always carried more weight than its practical use alone. Crops depend on it, yes, but it also stands for something larger, the balance between what people do and what the land gives back. Choosing to build this well by hand is the builder's way of reconnecting with a way of life her ancestors knew well. These projects are never just about what works. There's a careful eye behind every decision. Stones, soil, and bamboo are layered together to hold the land in place while giving it shape. That blend of solid usefulness and considered beauty is becoming something of a signature for a new generation of rural builders. Lifting the storage tank off the ground changes everything about how the well performs. Height does the work that a pump would otherwise need electricity to do. Water flows steadily, reliably, without added cost. What makes it striking, though, is that it manages to look considered and beautiful at the same time, taking something rooted in tradition and turning it into a quiet statement about living with intention. Bamboo fencing isn't just a practical choice, it means something. Those slender, upright stalks, spaced out in an easy rhythm, bring a sense of calm order to the space without cutting it off from the world around it. A fence like this isn't really a barrier. It's more of a conversation between the structure and the land it sits in. Elsewhere, river stones are laid out in circular arrangements that take the sharp edges off everything man-made nearby. Those corrugated sheets Lee hauled in earlier now have a clear purpose, holding the earth in place. The spot she's working on runs along a sloped bank right beside her garden fence, exactly the kind of terrain that creeps and shifts after heavy rain or rising groundwater. Standing the fiber cement panels upright along the prepared slope is the answer. Strong, barely absorbent, and built to resist the slow rot that takes down most materials over time, they're well suited for the job. The goal here is to reshape this stretch of land into a large pond, complete with a bamboo bridge running across it. That corrugated surface isn't just structural. Each ridge and valley presses into the earth at a different point, giving the panels far more grip than a flat surface ever could. Post holes go in at steady 1-meter intervals along the banks and pond floor, each dug to somewhere between 30 and 40 centimeters down. Going deep enough into the ground gives those bamboo posts a solid hold, enough to push back against the lateral force of wind. For the main vertical posts, which carry most of the structural load, only thick-walled, fully matured bamboo culms are used. Angled railings and a thatched pavilion at the far end give the structure a natural rhythm, drawing you forward while quietly asking you to slow down. Nothing here is trying to impress. Every piece speaks for itself, letting the work show without any added decoration. Across the horizontal beams, she lays shorter bamboo culms side by side to form the decking. Finished, the bridge makes a clear case for bamboo as serious structural material. That cylindrical form carries remarkable strength relative to its weight. Adding paint introduces a quietly modern note to something that, in every other respect, feels traditional. Right beside it, she maps out a circular foundation using ordinary perforated clay bricks. Starting at ground level, the bricks are laid in a radial pattern, spreading out from the center to form one continuous compression ring. Inside that, a second concentric chamber rises to hold a vertical water channel or a pump conduit. At the top, bricks are set flat to create a cap layer, with pipes running through to direct water outward. On a practical level, this works as a closed-loop water feature. A small, submersible pump keeps water circulating continuously. Those aquatic plants and potted flowers aren't just decorative either. They actively help filter the water. Still, this is far from finished. Several more water-related developments are ahead. First, the tubular columns go in. Round cross-sections aren't chosen arbitrarily. That geometry distributes stress more evenly, which makes each column stronger under load. Every column is set into its own concrete footing, and that mass below ground is what holds it against upward forces. The roof carries a slight pitch, barely noticeable, but enough to push runoff reliably toward the drainage zone at the back. Alongside this structural work, a small rectangular brick pool is also taking shape. Its size and the ducts already gathering around it make the purpose clear. This can work as a garden pond or simply a drinking basin for the birds. The electrical supply, meanwhile, most likely taps into a local transformer or shared rural grid, which is standard in the countryside. Most households here draw power from nearby communal lines through informal setups built around practicality over everything else. What this project proves, more than anything, is that building something is also an act of taking back control. By now it has become something tangible, a living expression of self-reliance rooted in how rural Vietnam is quietly redefining independence. Every system here connects to the next, forming an infrastructure designed from scratch to minimize reliance on outside sources. At the center of all this self-sufficiency is water, the most essential and the hardest element to manage on any rural property. The water wheel has been around for thousands of years for good reason. It's one of humanity's clearest examples of working with nature rather than against it. Here, that idea takes physical form. The wheel becomes the heart of a passive network of pipes, channels, and tanks. In traditional Vietnamese water culture, the water wheel goes by a name that says it all: Con Nuc. Built from bamboo, hardwood, and stone, these structures were central to keeping both fields and households supplied. Mountain streams did all the work, their natural flow guided through a careful arrangement of paddles and hollow bamboo pipes. With every turn, the wheel lifted water into elevated troughs and spread it steadily across terraced fields. No pump required. Simple as it looks, the system regulated itself. A faster current meant more water delivered, and a slower one meant less. When drought hit and the stream thinned, the wheel responded accordingly, drawing only what the flow allowed. Bringing this idea into a modern homestead means connecting old knowledge to present-day needs. Rotation, as it turns out, is potential, and the wheel's steady spin can be put to work in more than one way at once. Connect it to a vertical shaft, and it can drive a small pump, pulling water up from a pond and into an elevated storage tank. Route that motion through a belt or gear system and it can drive a low-speed alternator, turning rotation into usable electricity. Lee takes things further, modifying the wheel until it becomes a multifunctional power source capable of running mechanical tools as well. Adding an auxiliary output is what does it. The wheel becomes, in every practical sense, a kinetic generator. The main wheel, built from lightweight metal and reinforced PVC tubing, is what drives everything. Its rotation feeds into a horizontal steel axle held in place by concrete pedestals, which keep the whole assembly steady and dampen any vibration. Here is where the real ingenuity shows: the axle coupling. An additional output shaft redirects the wheel's motion towards secondary uses, grain winnowing among them. That sieve tray you'll notice later isn't there by accident. It's what happens when water-driven energy gets applied to the work of the harvest. The area around the water wheel is about to become the center of everything. First, though, the metalwork. Cutting, aligning, and welding rectangular hollow steel tubing into a solid frame. A BTEC inverter welder handles the joins. Clean arc, right penetration, minimal heat distortion for thin-gauge material. Careful weld spacing keeps the alignment true, building a lattice that distributes load evenly across the whole frame. With the frame in place, a high-density polyethylene mesh goes in next. Water passes through freely, but small aquatic life and organic matter stay put, which makes this setup well-suited to fish rearing. Running alongside this, bamboo rafts and supports take shape, lashed together with rope and natural fiber. These act as cushioning mounts, holding the metal structure steady and absorbing the vibration that turbulent water tends to generate. Wooden rollers and bamboo channels nearby round things out, showing a time-tested approach to redirecting and managing current. Once it's in the river, the green structure takes on two jobs at once. On the mechanical side, it works as both an intake point and a sediment filter, keeping large debris away from the wheel's feed line while holding water pressure steady through the pipes. This stretch of riverbank, as mentioned, grows into the working heart of her self-sufficient homestead. Anchoring the whole space is a bamboo platform and walkway that reaches out over the river. That pond at the far end isn't just decorative, it's the last stop in her water system, a basin where the wheel lifts water into storage that also doubles as living habitat. Simply put, this stretch of riverbank is both her workshop and her food supply. From here, she shifts focus to making the water wheel area something built to last. Everything starts at ground level, a reinforced brick and concrete foundation laid close to the bamboo grove. Once the ground is leveled, she combines sand, cement, and gravel into a solid mix, pressing stones into it as she pours the footing. Into that brickwork, she drives vertical rebar anchors, hammering each one firmly into place. Those steel rods become the link between the masonry below and whatever steel structure will rise above it. Above the foundation, she welds together a rectangular steel frame, the bare bones of a small shelter taking shape. Galvanized square tubing handles the job here, chosen specifically because it holds up against moisture and corrosion in a humid riverside setting. With the frame squared off and fully welded, corrugated metal roofing panels go on last. Sitting beside a thick bamboo grove with the river just beyond, the shelter fits naturally into its surroundings. That grove does real work here, casting shade and keeping the immediate area noticeably cooler and calmer. Engineering-wise, the location is well chosen. Close enough to the water for the system to run efficiently, but raised just enough to stay clear when seasonal flooding rolls through. This is where her approach shifts: less experimentation, more deliberate precision. That rail serves as the wheel's main mount, holding it steady against the sideways push of moving water. Working from that base, she attaches angled steel supports to cradle the wheel's central axle. Every support gets welded and braced with crossbars. Vibration left unchecked would wear the whole thing down far sooner than it should. Now's a good moment to step back and look at how Lee has been weaving water into every corner of the homestead. The water wheel is the engine behind something larger, a connected water network designed for working with the river's rhythms, not against them. Those fountains and smaller features may look peaceful, but they're doing real work within the system's self-regulation. Moving water between ponds and through cascades keeps it aerated and varied in its flow. Stagnation is avoided, oxygen levels stay healthy for aquatic life, and the circulation also evens out temperature swings while cutting down on mosquito breeding, quietly turning the space into a more livable microclimate. Everything here has a role. Moving water is the wheel's job. Storing it belongs to the ponds. And the fountains and channels keep it cycling through the system. Anything used for cleaning or watering the garden doesn't go to waste. It soaks back into the soil or returns to the ponds, which in turn keep the garden and the fish thriving. What happens next takes things a step further. The water wheel becomes an actual power source. Building a solid mechanical frame is the first order of business, something sturdy enough to hold the generator in place. Galvanized square steel tubing is her material of choice, cut to size and welded at right angles to form a frame that won't flex or shift. Connecting the wheel to the generator is then handled through a pulley and belt system, the link that makes both sides work together. Attached to the main axle, the large wheel acts as the drive pulley, while a smaller pulley on the generator side ramps up the rotation. Speed is everything here. A water wheel moves at a gentle pace, but a generator needs to spin considerably faster to produce a usable current. Getting the tension just right takes a bit of hands-on tuning, after which the generator frame gets bolted firmly into position. Mounting the generator comes next, with some sanding to make sure everything sits flush and clean. From there, the wiring gets tied into a straightforward circuit: a bamboo pole, a socket, and a light bulb. Every turn of the wheel sends that motion through the pulley system, which spins the rotor inside the generator's magnetic field and converts movement into electricity. Adding plants along the walkway is the finishing touch, the detail that pulls the whole ecosystem together. Underground, their roots do quiet but important work, holding the soil in place along the path's edges and around the concrete bases of both the wheel and the ponds. Lai doesn't stop. She keeps improving this place one upgrade at a time, pushing toward the best version it can be. For anyone curious about the full picture, wind power is a key part of what makes a homestead like this truly self-sufficient. Yes, the water wheel handles steady, reliable power from the stream, but wind energy fills in the gaps. On slower water days or through a dry stretch, the wind takes over. Together, these two sources cover each other's weaknesses and keep the homestead running independently no matter the season. Construction starts with something you can't miss: a tall, reinforced concrete column. Lifting the turbine well above the surrounding trees and the choppy air near ground level is exactly the point. Higher placement means cleaner, more consistent wind reaching the blades. None of that works, though, without a foundation solid enough to support it, so the work begins underground. A circular pit gets dug out, packed with compacted gravel, and then filled with poured concrete to anchor everything that follows. Inside the foundation, steel rebar cages are carefully wired together into a rigid internal skeleton. Handling the bending and twisting forces that strong gusts can put on a structure is precisely what this framework is built to do. Carrying the turbine's weight is only part of the task. The column also has to hold up against the constant vibration from the rotor spinning above. Without that level of reinforcement, the structure would gradually be worn down over time. With the base fully cured, cylindrical molds get built up around the rebar frame in modular sections. Rather than pouring the entire column at once, each layer is given time to fully harden before the next one goes on top. Patience here is what pays off. This approach keeps weak points from forming and ensures the concrete stays consistently dense from the bottom all the way up. At the very top, the column widens into a reinforced platform built to hold the turbine's vertical shaft in place. A circular railing wraps around it for safety, and set into the top surface is a metal bearing assembly. That bearing is what connects the fixed tower below to the shaft that will spin above it. The whole approach here comes down to an engineer's instinct for keeping things simple. No prefabricated components, no complicated gearboxes, just a system that anyone with the right knowledge can maintain with their own hands. On this homestead, the column is carrying more weight than just the turbine above it. What it really stands for is independence, a physical link between the forces already at work in the landscape and the energy demands of everyday life. Each piece, from the rebar framework to the bamboo scaffolding, reflects a clear philosophy: work with what you have and make it count. With the turbine sitting at the very top, safe access for maintenance, inspection, and repairs isn't optional, it has to be built in. So Lai integrated both a working platform and a climbing system directly into the tower itself. Up at the summit, a reinforced circular balcony with a waist-height guardrail gives her a solid, secure place to move around the turbine when needed. Next comes a ground-level concrete walkway, built mainly to stabilize the surrounding area and give clear circulation paths around the structure. The process starts by compacting the soil base, and in wetter spots, a thin layer of gravel goes down first to help water drain away. As a practical element, this walkway ends up doing more than one thing at once. For one, it gives solid, clean footing in an area that stays damp thanks to the nearby ponds and river. On top of that, it acts as a service path around the wind device. A level, reliable surface for inspections, adjustments, and any electrical work that needs doing. The density of the concrete and its smooth finish also keep weeds from creeping in and stop water from pooling underfoot. With the concrete set and cured, work on the wind device itself picks back up. Lai turns her attention to building the rotor blades. Each one has to be light enough to spin freely, wide enough to catch the wind, and shaped to move air efficiently. Bamboo, light wood, or salvaged aluminum sheet are the usual materials for this. The hub assembly then gets mounted onto a horizontal steel shaft, which sits inside a custom-built housing on ball bearings. To keep everything running smoothly and avoid wear on the structure over time, that shaft is lined up precisely with the bearing plate at the top of the tower. By the time Lee completes her homestead, what she'll have built goes far beyond a place to live. It's a self-sustaining, interconnected system. Even now, you can see the shape of it, a living structure designed to take care of her physically, keep her energized, and support her state of mind too. Every system she's put in place feeds into a larger model of rural life that doesn't depend on outside inputs to keep going. Within it, what comes in and what goes out move in balance, without needing anything from the outside world. Her daily life, in that sense, becomes one of steady continuity, reliable but never reliant. Everything she has built works together to hold that balance, drawing on local resources, renewable by nature, and kept alive through the way each part feeds back into the whole. Water being constantly available and clean changes everything. Lee can cook a meal, rinse her hands, or water her crops without a second thought. Energy independence runs on the same idea, a loop that keeps feeding itself. Food works the same way here. Her ponds aren't just ponds, they shelter fish, regulate temperature, and send their settled, nutrient-rich sediment straight to the vegetable beds growing nearby. Water drawn from the storage tanks keeps the soil at a steady moisture level, which means less stress on the plants and more reliable harvests. Living close to the river adds even more to what she can draw from. Fish, water plants, and wild herbs growing along the banks become natural extensions of what she's already cultivated. Organic scraps don't go to waste, they go into compost, closing the loop between what the land gives and what it gets back. That return fertility keeps the whole system moving forward. What really sets Lee's approach apart isn't the engineering, it's the rhythm. Her days won't be shaped by a power grid or a production schedule, but by the patterns of her environment. Even upkeep takes on a different quality here. It becomes something closer to a ritual than a chore, and her independence isn't a turning away from the world, it's a different way of being in relationship with it. Her connection is with the land, the weather, and the quiet logic that natural systems carry. Stepping away from the rigid pace of industrial life, her time becomes something fluid and responsive. Morning mist, how full the pond sits, the way the wind shifts, these are the signals that shape her day. Watching him put the final touches on the homestead, something becomes clear. The outdoor spaces here aren't extras. These aren't decoration or afterthought. They are functional, load-bearing parts of the home's living system. Traditional Vietnamese rural architecture has always understood this. The boundary between inside and outside was never meant to be a hard one. Courtyards, gardens, and open passages have long been part of how a home works in this tradition, not just how it looks. Lee carries that forward, sharpening it into a modern ecological model where every outdoor space acts as a living interface between human activity and natural processes. What she's building is a place where those two things don't just coexist, they work together. Walkways, ponds, and shaded courtyards all play a role in shaping the climate around the main house. Stone and concrete paths soak up heat through the day and release it slowly once the sun goes down, keeping ground temperatures stable and foundations drier. Plants and water bodies nearby do their own work. They cool the air through evaporation, keeping both inside and outside naturally ventilated. Together, these elements let the homestead breathe, functioning like a slow, steady lung that keeps conditions comfortable without burning a single extra watt of energy. Beyond climate, the outdoor areas carry real productive weight. Garden terraces and pond edges are where food gets grown, waste gets composted, and water gets managed. These aren't just useful spaces, they're beautiful ones, built on the idea that what looks good and what works well don't have to be separate things. Lai's homestead isn't a house placed inside nature. It's a habitat that nature runs through, built not in spite of the living landscape, but as a continuation of it.